To solve a right triangle means to find the lengths of all the sides and measures of the triangle. So if we want to solve this particular right triangle, then the first kind of easiest thing I can see I can do, since I have the one angle, it's a 28-degree angle, and I know the other one's a 90-degree angle, I can find that remaining acute angle. 90 minus 28 means the other angle here has to be a 62-degree angle. That's this one here. So that part's easy. And as far as finding A and B, I'm going to need to use my trigonometric ratios. So SOHCAHTOA. Let's see. If I have this 28, that's going to be my reference angle. And let's find A. Well, I know my hypotenuse. If I want to find A, that means I'm talking about my opposite side and my hypotenuse. So opposite and hypotenuse, that's the sine. So I know the sine of 28 degrees must be equal to A over 9.6. So if I'm trying to find A, I can just multiply both sides by 9.6. And thus A is 9.6 times the sine of 28 degrees. 9.6 times the sine of 28 degrees, which gives me approximately 4.5. This is in meters, it looks like. All right. Now, let's see if I want to find B. Rather than using A, because I've already rounded A, I don't really want to use that for anything else in this problem unless I absolutely have to. I'd rather kind of approach this again and say, okay, how about if I wanted to use the side that's adjacent to my 28 with this 9.6? Well, the side adjacent to the angle and the hypotenuse is a cosine. So I can say cosine of 28 degrees is equal to B over 9.6. Which means when I multiply both sides by 9.6, I get 9.6 times cosine of 28 equals B. So let me just change this here to cosine. And I end up with 8.5. Now, you can see I rounded this to 2 significant digits. This is really just because this one was rounded to 2 significant digits, to the nearest tenth of a meter. It really didn't make sense to me to have these to more accuracy, to have them more accurate than that one. So 4.5 would be this measure right here, and 8.5 would be this measure right here.